So one important note is you can think of a polynomial as a function. If you set a polynomial, one of those expressions I wrote above, equal to, like, if it has one variable f of x, then it will graph in 2 dimensions, the xy plane, and it will pass the vertical line test. Now, there are a handful of polynomial functions that I want you to be very familiar with. The first one is called the identity function, and it's given by the formula f of x equals x. So it's called the identity function because for any input, no matter what number you plug in for the input, the output is the same number. Now, you guys know how to graph this. You've done it before. If you make the input, say, -1, the output's -1. You get -1, -1 on the graph. If the input is 0, the output is 0. If the input is 1, the output is 1. And if you draw a line through those points, you get something that looks like that. So that's the identity function, and the point here is that it's a polynomial function, and it's a polynomial function of degree 1 because x is a monomial, and since it's a single variable monomial, the degree is just going to be whatever power is on the x. So it's a degree 1. The identity function is a degree 1 linear polynomial function. And it turns out any linear function is a polynomial function of degree 1. I mean, think about it. You could write down a generic formula p of x, p for polynomial, equals mx plus b, m for slope, and b for the y-coordinate of the y-intercept. In the identity function, m is 1 and b is 0. But that doesn't have to be the case for it to be a degree 1 linear polynomial. This is still a degree 1. The highest power you see on the single variable x is 1. It's still a degree 1 polynomial function. The next polynomial function I want you to be very familiar with is the squaring function, f of x equals x squared. So any number you throw in to the input, the output is the square of that number. And you've graphed more complicated equations than this, so we'll just do a quick sketch of it. So you know that if you input, say, 0, you know that the output is 0. So you get 0, 0 on the graph. If you input 1, the output is 1. If you input -1, the output is 1 because you squared -1. That's also an output of 1. And then you put in 2, you get an output of, you get an output of 4 because you're squaring the 2. 1, 2, 3, 4. If you input -2, you square out the negative and you also get 4. And if you connect the dots, you get something that looks like this. If you don't quite make it through your dot, you know to make the dot a little bit bigger as long as you're not too far away. You get kind of a U-shaped graph like that with this low point at 0, 0. It's called the vertex. That vertex is at 0, 0. That's the squaring function. Now that is a degree 2 polynomial function. It's a monomial, so it's a single variable. So you just look at the power on that variable, and it's 2. So it's a degree 2 polynomial function. The squaring function is a degree 2 polynomial function. There are other polynomial functions of degree 2. We'll use p for polynomial. P of x equals, just as an example, we could take -3, square it, add it to 4x, and then take off 1. -3x squared plus 4x minus 1 is also a degree 2 polynomial function. How do I know it's degree 2? Well, when it has more than one term, as long as there's just a single variable in the formula, you look at the highest power on that variable. So that's also a degree 2 polynomial function. So be able to identify a degree 2 polynomial function when you see it, and also be very familiar with the most basic degree 2 polynomial function called the squaring function. The third basic polynomial function I want you to be familiar with is called the cubic function or cubing function. It's f of x equals x cubed. Now keep in mind, I've been using inputs of x, but it would work to use like f of t for the input, and then you cube the t. It doesn't matter. The letter doesn't matter. So the idea here is that the input is some number. To get the output, you cube it. So this is a degree, no matter which formula you look at, this is a degree 3 polynomial function. And its graph is reasonably easy to come up with by just plotting points. Because if you input, say, 0, I'm not going to make a table here. I'm just going to... The point is you can do this in your head. You can graph this thing in your head if you just think a little bit about it. If you have an input of 0 and you cube it, f of 0 equals 0 cubed, oh, you get 0. If you plug in 1 and cube 1, the output is 1. If you plug in 2 and cube it, 2 cubed, 2 times 2 times 2 is 8. So go up here, 1, 2, 3, 4, 5, 6, 7, 8 would be up here. So an input of 2, cube it, you get an output of 8. An input of negative 2, the negative is going to stick around. Negative 2 times negative 2 times negative 2 will get you an output of negative 8. So the idea, I'll show you one of these. So the idea is f of negative 2, you take that input, you cube it, that's why it's called the cubing function, and you get negative 8 popping out. That's this point right there. Oh, and then the one I didn't put in was an input of negative 1. If you cube negative 1 times negative 1 times negative 1, you also get negative 1. Okay, so connect the dots in a nice smooth curve. Close enough. And that's the graph of the cubic function. Now, there are other degree 3 polynomial functions. I could use, say, like p of t. As just an example, I could use like 3t cubed minus 5t squared plus 2t minus 8. Just scan for the term with highest degree, and you see that it's 3. So this is an example of a degree 3 polynomial function. But again, the one I want you to be very familiar with and be able to graph is the cubic function.